Let's learn how to build Fall Guys hexagon clone with React Fiber, Wawa guys, and we will ship this on Discord. Discord recently launched Embedded App SDK, allowing you to build activity games playable directly within Discord. This opens the opportunity for all developers to reach a big user base with just a few steps. If you are not familiar with Activity, you simply need to join a vocal room and then click on this rocket to start an activity. You can launch any game to play with friends and community. We will use Discord Embedded SDK along with Playroom Discord Kit. This will help us to build games faster without any need to set up a multiplayer server, handle URL mapping, proxy authentication. Instead, we have a smooth integration that has the scale to handle Discord's millions of users. We will start by creating the project as a multiplayer 3D web browser game, then we will see how to turn it into a Discord activity. Let's start by cloning the starter pack repository that I created for you, link in the description. Open a terminal, git clone and paste the URL. Once it's finished, file, open folder and open it. Then run yarn to install the dependencies and yarn dev to start the development server. Then you can follow the link here. This is what our starter pack contains. So it is the character 3D model, an hexagon tile that I prepared using Blender. This is my most advanced Blender skills, and a simple UI using Tailwind. So a logo here, a number here to add the timer later, and an icon to enable or disable audio. Nothing very advanced. If you are new to Three.js, I created React Fiber, the ultimate guide to 3D web development, a project-based course to learn everything you need to know about React Fiber and how to give life to awesome 3D experiences. Link in the description below. A golden ticket to win the course for free is hidden in the video. Let's start by displaying all the hexagon to create our game arena. So go into Component Experience. This is where we have our environment for the lighting, our character, and the hexagon. We can remove the hexagon from here, create a new component that we will name game arena.jsx, create a boilerplate, return a group inside, and inside our experience, use the game arena here. Now let's head to our game arena and add our logic to display all the hexagon. So we need some variables to do it. We will need the space between tiles on the x-axis, also on the z-axis. Of course, it's not random values that I found, but I tried and found it was the best. Then how many rows and columns you want. And the floor height. It could be named x, y spacing, so on the vertical axis. Then we want to have different floors. So let's create an array of floors containing the color it is. So red, blue, green, yellow, and purple. Of course, you can adjust the colors and add more or less. Now inside our group, let's render the different hexagon for each floor. So first, what we want to do is to center the main group containing everything. So on the x-axis, we subtract the half, and same for the z-axis. Then we will loop through each floor. Inside, we create a group at the height of the floor, multiplied by the index, so for each floor vertically. And inside, we loop through the number of rows, so from 0 to, what did we put, 7. We create a group and we position it on the z and x-axis. And then inside, we put our columns. And for each of them, we will display a hexagon that we will position it using the number of the column it is representing. On the x-axis only, because the position of the row is done by the parent group. And we pass the color as a parameter to our hexagon. Don't forget to import the hexagon. And this is what we have. So for each floor, we have one color with all the different tiles. Red, blue, green, yellow, and purple, the last one. That is at the very low Y position. To make it more interesting visually and to copy what Fall Guys is doing, we will add a random color based on the color of the tile. To do this, let's head to the hexagon component, which is loading our hexagon 3D model. We will compute a randomized color with a use memo because we just want to make it once when we have the color that changed here. We create an altered color from the existing color, and to change it, we use multiply scalar with the run float from 0.5 to 1.2. So either darker or brighter based on the original color. And we return it to have access to it inside randomized color. So here we can use our randomized color instead. And this is what we have. We had nice shades between the different tiles to add some dynamism and make it more visually appealing. Feel free to adjust the values here for a different effect. To make our game multiplayer, we will be using Playroom Kit. So let's follow the installation guide inside Setup. We need to install Playroom Kit. Run yarn, add and paste Playroom Kit. Then let's head to Making Multiplayer. And we need to use Insert Coin to enable Playroom inside our experience. We need to do it at the very beginning. So inside main.jsx, we call Insert Coin. We'll use the parameter skip lobby because we will create a custom one. And then once it's done, we will render our React app here and let's go. So far you won't see a huge difference, but if you look at the URL, automatically it joined a room for us. And multiplayer is ready to be used. Now we have multiplayer enabled inside our project. We can create the main logic inside the game state. Let's create a hook inside the hooks folder. New file, use game state.jsx. We'll be using a context, so const game state context is equal to create context. Then we'll be doing a game state provider. We will return game state context.provider and children. And finally, export const use game state. We don't want to return this like this, so const context is equal to use context of game state context. We throw an error if we are not within a game state provider, and it's fine. So this is an empty boilerplate when we are using a context. Let's create the logic order of our different stage. So let's create a next stage dictionary containing for each stage the next one. So after the lobby, you will have a countdown before starting the game. When the countdown is finished, we will be in the game state. If the game ends for any reason, we will show the winner. And after the winner have been shown to everyone, we will head back to the lobby, being able to start the game and repeat the process indefinitely. Then we will need some timer for each stage. So for the lobby, we set it to -1 because we can just wait indefinitely that we press the start button. Then the countdown will be using 3 seconds, but you can adjust. For development purpose, I recommend a low value. Then the game 0 will start at 0. We don't want an end to our game just when everyone dies or if players disconnect. And then the winner will display it for 5 seconds. Now let's define the state that we will need inside our game. So we need the current stage based on the definition here of next stage. And we are using use multiplayer state from Playroom Kit, which means that when the host is changing the value here of the stage, it will be synced across all the different clients. Then we need the timer and we set it by default to the lobby timer, which is -1. Then we have an array containing our players, and this is a local state. And same to define if we are in a solo game or not, because if we want to dev and try it alone and want to play alone, we need to know if we are in solo game or not when we will define who is the winner. Because we don't want all the different clients to define the variables, but just to have one that acts as the lead, we have a variable which is called isHost when we are using Playroom Kit. it is defined automatically, and each switch, if the host disconnects, it will assign a new host to another client. Let's init our players list based on the different events we will receive through network. So in a use effect, to make it only once, we will subscribe to onPlayerJoin event. All clients need to do this to have the players list synced correctly. Then we create a joystick from Playroom Kit of type Angular with the button to jump. It will add on the screen some controls to be able to play on mobile device and to have the state of that joystick synced through all the clients. Then we define a new player object containing the state of the player and the controls we just created, and we add that player to our existing players array. And we also handle the disconnection. So set players, we filter the player that is exiting from our list of players. And because we are using React in strict mode, in development, it might call the use effect twice. And we don't want to subscribe to onPlayerJoin twice. So what we can do is create a isInit reference. Don't forget to import it. Then add if isInit, we return. And if it's not, we do the next and we set isInit to true. Let's try to see if we have our joystick. So what we'll need to do first is go inside app and wrap everything inside a game state provider. So our canvas and the UI to have access to the state. If we reload, here we have the jump button and we have the joystick here. We will also add keyboard controls to either play on mobile mode or directly inside your desktop. It does nothing, but we will add it later. Let's head back to our game states and finish the logic. Now let's set up our timer logic. So inside a use effect, when one of those variables change, the host, timer, stage, or solo game, what we will check first, if we are the host only, the host will be the master of the time. So what we check also, if we are in the lobby, we don't want to play with the time, so we just return. Otherwise, we will set a timeout for every second, so 1000 milliseconds. And what we will do is we will check what is the new time. So if we are in the game, we will increase the timer so we can see how long is the game. Otherwise, we just decrement, for example, the countdown or the winner phase. Then we check if the new time is 0, which means we are at the end of the time. And what we do when it's at the end, we want to go to the next stage. So based on our current stage, we go to the next stage. So lobby, countdown, countdown game, etc. We set our stage to the next one. Then we check what is the new time based on the timer stage of the new stage. And we set the timer with the new time value. Finally, we return a clear timeout. So when one of those variables change, it will cancel the previous timeout. And finally, because I'm sure you want to dive into the 3D part, let's add a start game method. So what we do is we set the stage to countdown. So we set the timer to the countdown value. And then if there is only one player inside our list when we do the start, we'll set solo game to true. But if someone joins, we should set it to false. So maybe we should set solo game to either 1 or not. Now let's share the variable that we want to have access from when we use game state. So we need the stage, the timer, the players, the host, and the start game method. Now let's connect our start game method to start our game state logic. Head down to UI, and inside we will plug everything we need to. We will need the following variables, the timer, start game method, to know who is the host and the stage, from our use game state. We can play an animation with the background when we are in the lobby. So if it's lobby, we'll put a black transparent background, otherwise it will be transparent. Now let's render our timer here. But because by default it's -1, we will conditionally render it only if the timer is above or equal to 0. Now let's add the start game button. So if we are in the lobby phase, and if we are the host, we will display a button with the start game. But if we are not the host, we will just display to the user, waiting for the host to start the game. Let's try it to see if it works. We have the nice transparent background. We can make start, 3, 2, 1, and then we have our game. And the timer now is increasing. And if we try with 2 tabs, one is the host and have the start button. The other one has waiting for the host to start the game. And when we start, it's synced between the two clients, and then the game starts. We are now ready to add physics engine to our game and move our character. To do this, we'll be using @react3/rapier. Let's add the dependency yarn add @react3/rapier. Now it's installed, go to the app and wrap the experience with physics. It will enable physics engine inside our experience. And to be able to visualize what it does, we can add temporarily the debug prop. Now we will need to add physics to our model. So we'll go inside experience and we will create a character controller to put inside our character, which will be only the rendering. So components, character controller.jsx. And here it will be the logic of the keys and the physics. Export const character controller is equal to, we will need inside to know if it is us, the player, so we'll be able to make the camera follow our player. Then the controls and the state coming from Playroom that we have inside our game state, and then the rest of the props. So we will return a rigid body with the rest of the props, and inside we will add our character. We can size our character using scale is equal to 0.42. We also pass it its color from the state, also its name, so we can display on top of the character, and a position of 0.2. Before enabling movement on our character, we will enable collision. So we set colliders to false, and we will create a collider manually. So we'll be using a capsule collider that you can scale as you want and define its position to fit the shape of our character. Let's see what we have so far. So instead of displaying in experience character, we'll display all our players. So in experience, we'll get access to players and stage with use game state, and to me with my player from Playroom Kit. Now we want to render conditionally our game arena only if we are not in the lobby. And we loop through all our players. We have access to the state and controls. We'll render a character controller, passing the key. For the key, we'll be using the ID of the player. We pass the state, the controls. To know if it's us, we compare the ID of that player to me.id. So it's my player. And a position of 2 to be above the first hexagon, so we fall at the beginning of the game. Let's see if it works. So if we reload, we can see our character is falling because we didn't add collider to our hexagon. Let's fix it. Open hexagon file. And instead of using a group, we will replace it with a rigid body. We'll change its type to fixed because we don't want it to be impacted by gravity. We want it to be at a fixed position and to block our character. We'll name it hexagon. And for the colliders, we'll be using an automatic one that will use hull. So it will wrap around our hexagon. Let's reload. And we can see our character is falling, but then it falls inside. But you can see here our hexagon, they are perfectly wrapped by their collider. So let's fix our character now. To avoid any issue, let's set can slip to false. We always want our rigid body of the players to be active. And what we will need to do is to lock the rotation. So what we do is we enable rotation only on the y-axis so we can turn, but it won't rotate on the x and z axis. And we need a reference to be able to move our rigid body. So let's name it RB and create our reference. So const RB is equal to use ref. Before coding the logic, we need to add keyboard controls. So we add it in the app. This way we can register to keyboard events. So we define a controls with all the keys we want to handle. We define it in a map with use memo, and the control we define, so forward that we have here, correspond to either arrow up or key W, and so on for the rest of the commands. And that on top of everything, we wrap within a keyboard controls. And it's coming from dry library. Now inside our character controller, we will be able to register to these events. In character controller, we can do use keyboard controls, but I don't see what we did. Oh, I made it on the hexagon. So can sleep and enable rotation, and the reference have to be for the character controller. My bad. So we also need to take the use reference here, go back to character controller and define it here instead. We will declare two variables in the air to know if we jumped, and landed to be sure that we reached the floor. Now in a use frame, let's handle the logic. So if we are in lobby or in game, we do nothing. Then we create a rotation velocity and get our current rigid body velocity. Then we get the angle of controls, and we get the X and Y position of the joystick by doing some math calculation. Once we have it, what we do is we check if control is forward, so the key, or controls.isJoystick pressed and joystick Y below -0.1. So this is when we use the control from Playroom Kit, so the visual stick we have on the screen. If it's one of the two, we move forward or backward. We do the same for the side, and we rotate our y-axis. Now we have our variable defined. We set the angular velocity to the rotation velocity that we have, and we apply the allure to move in the correct direction. More explanation about that in my React 3 Fiber course and the physics lessons. Then what we do is when we press the spacebar or that the button jump has been hit, we check if we are in the air and landed on the ground. If it's the case, we can jump, and we will increase our y velocity of the jump force, a constant that we will define. If it's not, because we want to keep the impact of the gravity, we set velocity of y to be equal to the current one applied to the rigid body. Then, based on our current y velocity, we will define if we are in the air or not. If it is over 1, then it means that we jumped or we fell from something. If not, we can say we are not in the air. Then we apply those calculations to our rigid body, so set linear velocity, and we share it through the network for the other clients. So set pose is equal to our new rigid body translation, and the rotation to our new rigid body rotation. So this is for us when we are the player. But when we are another client, a remote client, we will check if we are not the player, so it's the others. We'll just get access to the state of the other player through the network and apply it. And then we return. On top of your character controller, you can define the movement speed, the jump force, and the rotation speed. And we also need to have access to the stage, so don't forget to add it here with use game state. If we reload, hit start, we can't move. And when the countdown is over, we can move. But we can't jump because we never landed on the ground. Let's add the detection of the collision between the hexagon and our character. First of all, we can disable the gravity if the game didn't start, so we are in the air. Then on collision enter, if the other rigid body object is the hexagon, because we defined the name to hexagon here, if it's this and not a player, for example, then we'll say that we are not in the air, that we landed on the ground, and we can just define our current velocity to 0, so we are sure it's not causing issue, and then we apply it. Let's try it. So now we can see we are in the air, then we jump and fall, and we can jump. And with this logic, if I just fall, I can't jump because I'm falling already. Now we can go on up and disable the debug on physics, so we don't see the rigid body anymore. On our character controller, let's define it with a name. So if we are the player, we name it player. If not, we name it other, to detect collisions between the hexagon and make them disappear. On the hexagon, now we will add an onHit callback to make it disappear, and a hit. If we are hit, we will make it disappear. Because we don't want to make it disappear as soon as we land on it, we'll add a state that we name disable. Let's define a time after hit, so after 600 milliseconds, we will finally disable it. In a use effect, if it is hit, so what we do, we set a timeout and we set disabled to true. If it is disabled, we return null, so our rigid body will completely disappear and will be removed from the object tree. Then on our rigid body, on collision enter, if the other is the player, because we want only ourselves to tell the server, to the other clients, that we broke a hexagon. So basically we trust the clients inside our game logic. And if it is the case, we call onHit. To make it visual, we can create a reference to our material that we name hexagon material, define it on the top here. And in a use frame, if our hexagon is hit, but it's not yet disabled, then we will lerp our current opacity using our current value into 0. So it will become transparent. And with a delta multiplied by 1.2. You can adjust the speed of the effect to your likes. Now we need to handle the onHit and hit inside our game arena. We will create a state to know exactly which one have been hit or not. So in a use state, we will just create a dictionary. We'll be using RPCs from Playroom Kit with rpc.register to hexagon hit. So when all our clients receive it, we'll get access to the data that is put inside the RPC. And then we will define set hexagon hit with all the previous data value. And we set hexagon key to true. Now we can go to the hexagon and add the different event. So on hit, what we will do is we will get the hexagon key by using the floor index, the row index, and the column index. So all our hexagons can be contained within this key. And then we set our hexagon key to true. So this is locally. And then we call hexagon hit with hexagon key as the value and to all. So everyone will receive it. We could put other because we do it locally. And then to know if it's hit or not, we will just add hexagon hit based on the key for that hexagon. Let's try it. We fall, it becomes transparent. We can move, and when it disappears, we fall. For a better effect, when the hexagon is hit, we'll display an orange color instead of the randomized one. Let's try again. And now it's better. Let's make the camera follow our character. To get the ideal position inside our rigid body next to the character, we'll add a group, an empty group, that we'll use to have access to its position and a reference to it. On top of our component, we can define that reference. We can also create another reference for camera look at to be able to lerp smoothly to the new position. Now inside our use frame, if it is us, the player, we'll get access to the position of the rigid body. We will look at that position and lerp to that new position. We also lerp the position of our camera. Let's try it. The camera goes in place. We can move and turn. Now let's animate our character. In a state, let's store the animation of our character with use state. By default, we'll set it to idle. At the end of our use frame, let's add the logic for the animations. So first of all, we want to get the movement. So we add the velocity of X and of Z to know if we are moving. So if we are in the air and the velocity is over 2, we'll say we are jumping up. If we are in the air and our velocity is below -5, which means we fall from a high value. Then if we are moving or if we are in the air, we set our animation to run. Otherwise, we go back to idle. And we set our animation locally and we put it inside the state of our player too. So we also need to make it when it is a remote client. So here, where we get the position and rotation, we also get the animation and set it to our local state. Let's pass the animation to our character here. Animation is equal to animation. So by default, it is idle. Then we fall, we run, we jump. We have the correct animations. Let's see if we add two characters. You can see that one on top of the other. So it's not ideal. We need to define their starting position, but it's fine. We can see the other characters and the other hexagon broken. So it's correctly synced. Inside our game state, what we will do is on player join, if we are the host, we will set its state to dead if we are already in game, because we want only players that were here from the very beginning, so it's not unfair for the others. And we define its default position. So we create a starting position. On the X, we are using a random value between the number of columns on the X-axis and on the Z-axis based on the rows. Then we handle those states inside our character controller. So go just above the return. And if we don't have a starting position or if we are dead, we return null. We don't want to display our rigid body. And instead of using the X and Z initial position from the props, we will be using the starting pose.x and z. And let's define isDead on top of our file. Now we have our two characters by default that have random position. Let's create the logic to define them as dead. At the end of our use frame, if our current translation is below the last floor and that we are not already dead, then we set our state to dead, or we also set it on the network. And again, we trust the players here, so it's not a very competitive logic to have. But for a casual game like this, it's better to do it because it works perfectly. Now we need to handle when there is only one player alive. So we go to use game state. We will create a new variable to store our winner. First, when we go to a new stage, we can check if it's the lobby or countdown, and we can reset all our players. So we can reset their position and that they are not dead. And then if new time is not equal to 0, and if we are in the game, we'll check if we have some players alive. So if we are in solo game, we just want to have one player alive. If not, the game is finished, everyone is dead. But if we are in multiplayer game, we need 2 players alive at least, or the game is over, which means we have a winner. So if it enters in one of those conditions, we set the stage to winner, and we define which one is the winner. And so we can change our timer to the timer stage of winner. Now let's prepare a component to visualize who is the winner. So we open our files, new component, and we'll name it podium.jsx. Let's create the podium. Inside, we want to know who is the winner. But if we don't have access to it, we want to know who is the last one that is dead. We also get access to the camera to put it at a new position in a use effect. So when podium is mounted, we set the position to what we want to be a nice position to view the winner. And when we unmount the podium, we will restore the position to the initial value. Then we return a group containing the character, so not the controller, just to display the player avatar, and a box which acts like a podium. Let's add it to our experience. So here, if the stage is equal to winner, then we will render the podium component. Otherwise, we will return all the rest that we had so far. So let's try it alone first. I'm here, I can jump here. I'm dead, but why do we still see the game arena? Here it's conditional, we have game arena here. Oh, I had another game arena. I think it was causing some lag issues. Let's play again. So 3, 2, 1. I'm here, jumping, deliberately fall, and I'm on the podium. We should add the character name, 3, 2, 1, and we are back in lobby. We can play again, perfect. To add the name of our character, it's very easy. Go to, it's not character controller, it's character here, and we always added the name, so it will be fine, character, and we'll add the text component. We add a group next to the scene. We create a reference to it, so we'll make it face our camera always to be readable. We add the text once and a second time, so with the white and black color, so it's always readable too. We create our reference of the text, and in a use frame, we get access to the camera. If we still have text, then we will make our text to look at our camera position. Let's try it. We have fire truck 18, can put start. And now it's facing me. Every time I can rotate, it's nice. Let's also add the list of the players here on top. Go to UI. Let's also get the players from use game state. And then on the top left, when we are on mobile, or on the top center when we are on desktop, we loop through all the players and we display their picture and their name. So with one player we have fire truck, and with two players we have both name. If one of the player die, we have it appears as dead, and we have correctly the name. Now our game could work as a standalone, and you can make it available online and have the multiplayer enabled, but now let's add it to Discord activity. To make our game available through Discord activity, let's simply follow the guide from Playroom Kit. Let's jump to the setting up section. We have screen to know exactly what to do. So first we need to create a game project on Playroom Dev Portal. So let's open that link. Create your account, it has a free tier. Then click on New Project. I will name it Wawa Guys. Hit Continue. Then we have guidelines to know exactly what to do. So in our insert coin, we need to add our game ID. So let's copy it. Our insert coin is located in the main. So we had skip lobby. We will also add game ID is equal to this. Well, it's a string, I guess. Then once it's done, enable Discord in your game. So we added game ID, we need to add Discord. So then Discord is equal to true. Okay, it looks the same, but we have skip lobby in top of that. The rest is exactly what we had. So we can run our game. So now it's good. We need to click on Discord activity tab. So here it is, Discord activity. Create a Discord application inside the Discord developer portal. Let's open that link. Let's create a new application. I name it again Wawa Guys. I accept the terms of service and hit create. You can add your icon, your description when you want to make your project live, but for the moment we don't need it. What we need to do is copy the client ID and client secret from OAuth2 tab of your Discord application. So go to OAuth2 and copy client ID, go back to Playroom, paste it, click on reset secret and it will display your secret key. Go back to Playroom and paste it in client secret and then save. Once it's done and saved, we need to add a redirect URI. So for example, wawaguys.playroom.gg if you host it directly on Playroom. But first we want to test it locally, so we need to create a URL temporarily to be able to test it on our development server. So we need to follow the documentation from Discord. What they say us to do is to run Cloudflare tunnel URL and the URL of our server. And this is the same that we are using. So keep your development server running, it's very important. Then in a new terminal, run npx if you don't have Cloudflare, then Cloudflare tunnel and keep it as is, hit enter. It generated a URL, a quick tunnel to our local host. So now we can use it as a redirect URI. Inside redirect, we add that URL and save changes. Then we need to enable activities and mapping Playroom backend. So root mapping is our URL. So it's inside activities getting started. We accept it and get started. So it generates URL mapping. If you want it to work on iOS, Android, which our game does, so let's enable it. Hit save changes. Now we can go to URL mappings. The slash is the URL of our game. And the second one is _WS, this target. So add another _WS and paste the join Playroom link. Then save changes. And we are done with the setup. We can try it. If you want to test it, open a voice channel inside Discord, open the chat and start an activity here. And then you can choose Wawa Guys or the name of your project. Say, okay, continue. And here it's opening the activity. So you need to authorize it. And it's loading the game within Discord here. We can click on start and have our game running as anywhere else. But you don't want to play alone, you want to invite friends. So let's add an invite button at the beginning. So next to waiting for the host to start a game, we add another button and on click, open Discord invite dialog. Now, if we open back Discord, we have the start, but also the invite button, and we can invite our friends here. If you have any issue, and I will talk about common ones just after, you can debug that component here by opening Discord in your web browser and opening the inspector. So one issue you can have when your game is running properly but not inside Discord is the fact that the proxy is very non-permissive. So you need all your files to be local. So what you can see in the starter pack that I provided, if we go to character, when we are using use GLTF, we are using a second parameter, which is the path to Draco, which is the uncompressor of a GLTF file. And it's set here Draco/GLTF. It's in public Draco, I added it. If you don't set this path, it's using the remote one, but it will be blocked by Discord proxy. That's why you need to have it locally. So same if you are using on experience, the environment, usually I use preset, but the presets are remote files, so you need to have it locally in your project on the same domain. So I downloaded one and added it to the project. Same for everything. If you go to character, we are using a font here, which is inside the project in the public folder. Last but not least, when you host your project or you restart your tunnel, don't forget to update the URLs so it works correctly in development and in live mode. Let's add the final touch to our project. We want to move the camera when the countdown is starting, so we have a nice transition. In the experience, get access to the camera, and in your use effect when the stage change, if the stage is countdown, we set the position of the camera to be behind instead of in front, so we will have a nice smooth transition. And also when we are dead, we want to follow other players if there are any other live players. So what we can do is get access to the first non-dead player by finding the first one that is not dead. Then we can pass it to our character controller, and inside the character controller, add it as a prop and change our condition here for the camera. So if we are the player and we are not dead, or if we are dead, then we display the first non-dead player and we follow that player with our camera. Let's try it in Discord. We can play start. We have the camera going from back to our player. It's way better than before. We can play and it's nice. Last thing, let's add audio. So in the UI, we already have the logic to enable or disable audio. Because when we are playing audio, we can't play audio automatically in the web browser. As we need the user to interact with the page to be able to play audio, I added a button to enable or disable audio. And by default, it is disabled. We can play audio when we are dead in our character controller. Access to the play audio function from use audio manager. Search for set state of dead, and we play the audio that we are dead. Also on the hexagon, we want to play some audio. So let's import the use audio manager and its play audio method. And when it's hit, when it's disabled, we will play audio, a pop song. So it's a noise, and I created 5 small variations of it. So it's a better effect than just playing the same audio every time. It's a slight pitch difference, but it makes all the difference. And then in the podium, in the main use effect, here we can play audio. You can see the true parameter here of play audio, it's to force the audio to be played. If we look at it, I made a force parameter because if we just played a pop sound and we have 3 or 4 more hexagons that are destroyed at the same time, it would be so loud. So it requires a delay of 100 milliseconds if it's not forced to play another sound. I provide you some royalty-free audios inside the folder. The background music is not the same than mine because I don't have the right on the one on the final project. But the background that you have is one that I made years ago. Now it's time to invite your friends and play. Thank you for watching. If you find this video useful, please hit the like button to make it more visible to our developers community. Don't forget to subscribe to not miss my upcoming tutorials. In the meantime, you can continue learning React with Fiber with my course or my existing videos like this one here.